Hello, welcome back to our CSCI 340, our database. And for today's lecture, actually we'll be repeating related to the relational database retrieval. That means that if you already did it, and also if you came to the class like in previous lab, so I think cover you already complete all this part. So just like our revision, like what we did before. So we'll go through slightly more about what's the SQL, the SQL as the like relational database manipulation language, and also how can you create, update some like relational tables using the SQL. And basically, we will use the SQL select commands to retrieve the data. Okay, so for also with different operators. So I think most of you already use the select. Okay, so basic and then group by, order by. Also there's some like built-in function including FH, sum, maximum, minimum, and count. In practical in our lab, I already give you some exercise. So if you already did that, I think you're pretty easy to catch up with this lecture. So basically, we will learn what's the select statement that's we covered in last lab, and then what's the like the subqueries. Also, what's the strategy for writing the SQL select statements. Also, what's the principle of like how a relational query optimize works. So we'll talk about that. So basically, we go through for the data management in our previous lecture. We talk about that. So once the data definition, and also we relate to the data manipulation. So we'll be like two type of management we're going to do. So what's the definition? The definition is the operationalized with the data definition language. We call it DDL. Okay, so it instructs the DMS software on like what tables will be in the database, and what attributes, that means the columns, okay, will be in the tables, and which attribute will be indexed, etc. All this one will be the data definition, okay. If you recall back to our sample database, then you can match with all this. And then another one is called the data manipulation. Okay, so there will be four basic operations that can use and also must perform on the data stored in any DBMS, any of them. So will be data retrieval. Okay, so how can you select update? Okay, update the data, update the table. How can we insert new records and then delete of existing records? All this. Okay. In the beginning, I think we already covered is the retrieval. Okay, but we not yet talk about like how to create table, also like update data, not yet in this moment. And although say requires data manipulation language, DML. So you see it's a DDL and then the DML. So it's the called data definition language and also the data manipulation language. Okay. And all these like we can like using the called the structural query language SQL. Okay, so some I call like SQL SQL. So it's incorporates like both the DDL and DML features, all this. And so far, all the example in coming this lecture we're telling you. Okay, so you can refer to these slides. Okay, the slides right here, or you just look at the previous lab. So I think you can do it. In the beginning, when we building the data structure, so we do have some like base tables, right? So actually physical tables in which the data like will be stored on the disk. So we really create it. So if you open the SQL data import, okay, import a file. So you'll see we try to create the tables using create table command. And then we can delete the table using the job table. But later in practical, I will let you to do that. And we do have some like called logical views. This is a term we call it a view. Okay, so it may consist of a subset of the columns of a single table, also a subset of rows of a single table, or both. It can be doing that, and also maybe join of like two or more base table. Okay, we also like mapping onto base table. We can do this, and we can use a command. It's called create view. Later we will know like how useful of creating view, because if we always like selecting, or like we have to select certain result based on the selected like the output. then maybe better to create a view. Like it can help us to access faster or retrieve it from the view. So it would be better. It's called a logical view. And the manipulation operation, including update, insert, and delete. So we can use update this manipulation operation. So update existing data. Then we can insert new row. So we can use it insert and then delete. So we can delete existing. Of course, like when you look at this example, and then later in the lab, we do also cover all this. And for the SQL sled, so you use like for data retrieval as well, so you need to specify which data you are looking for rather than just provide logical sequence of steps. So it guiding the system like how to find the data. So it can run like either queries or an embedded mode. So either way. So later you see maybe the command also work with like Oracle, MSSS, SQL Server, okay, DB2, like Informatics like this, okay, different platform. How do they recognize or sometimes the syntax may be slightly different for all these, okay, MS like SS or Oracle, okay, and slightly different, but basically they are all the same, okay. So just like we helped you to recall what we did before, so we start with the select. Here's the column. So the select is like what is going to be presenting, what you see. Okay, so it's more important. You need to recognize. If I ask you a question, okay, if I want to have certain columns, okay, or I need to see certain data, so you need to put it right here, like in the column, this part, and then from which table. And always remember we close with the semicolon, okay, select from, and of course we are adding the condition, so we can like predict, identify the row to be included, so we can put where condition. So the basic syntax will start from select from semicolon, and then we can add the condition where. So because most of the time we were selecting certain data like with some condition we need to identify, and it's a basic way. If you see all these like from different tables, like right here is a called company database. Okay, so for and we have different columns. Okay, so here for just like general idea. If we say we need to find the commission percentage and year of hire of salesperson like number 186, then you say, okay, I want to find the commission percentage and then the year of hire and salesperson number. So this one is like giving the condition is like which person, salesperson 186, salesperson number. So we need to find the matching. So first you need to check like which table, salesperson table. Okay, let's go to salesperson table. What is the condition? Okay, we given condition, and then what kind of data or information we need to present. One is the commission, and then one is the year of hire. Then we need to find the commission percentage and the year of hire. Okay, so like this. So right here we have design attributes list in the select. Okay, this clause, and then we put the required table list from. Okay, and then where. So the restriction. Okay, predicate. Okay, so indicate like which or the condition we're going to use, like which row involved is shown. So we're using the use where clause in the form of this like an equation. So we can show in this result. So I think in practical, I think in the lab, if you already follow all the lab what we did, I think you have a pretty better idea. I think you already know it. If you have not yet or some attempt online, then you can review from this one or try to do the lab. Okay, and right here we can see is a result which we try to retrieve entire record for the salesperson. If we putting the star extra right here, so we can getting the whole the columns. Okay, so from the salesperson. So this one is giving condition. So you need to be careful. Okay, so when we're putting the extra or star right here in the case all attributes. Okay, so if we didn't put the condition, then we'll show all the records. That means all the rows. And just give you one more, if we need to give in the number, okay, list the salesperson number and then salesperson name. So if you see the question like this, that means we need to show the numbers and then the name of like those salesperson have a commission percentage of 10%. Then we need to put the condition is 10% of the commission. like this way. So then we can put the search argument. It's not like unique in this query. So you need to be careful. So it's pretty straightforward, easy. So you can see all these example. Or another example is like saying list the salesperson number and salesperson name or of the salesperson. You just need all them. So right here, I didn't need to put any condition where, okay, but I just need to show their salesperson number and name. So you just need to select this column, okay. So in here we see the relational algebra project operations. So there's no need to put in where right here to limit which row of table are included. So you can see. And then if we need to retrieve of the salesperson, straightforward. I think in the first assignment you were doing it like select all the content. So we try to retrieve entire tables. Okay. So the query places no restriction on either the rows or attributes. And then we do have some like comparison. So the basic, I think most of you already using the equal sign. Okay, the standard comparison operator also can use, they are like greater than, less than, greater than or equal to, less than or equal to, or not equal. So be careful, we can also using not equal right here. So if let's say we have a question, we say I want to list all the salesperson except number 186, then you can use a not equal to. Then we can do it in this way. And you can see example right here that we were looking for the salesperson's number, name, and their commission, where their commission percentage is less than 12. Okay. Sometimes just like be careful of the question. Like sometimes say less than equal to. So just like be careful, then you need to put the correct operator. Okay. Quickly we go through if we're using like greater than or equals to 1700. So at least if you see some have a custom number of at least. So if we're using at least, it should be more than 1700 like this. Okay. Or sometimes we will have like multiple condition we need to fulfill. So right here say list the customer number. Okay, customer number, and then customer name, also the headquarters cities of the customer. They are headquartered in New York. Okay, so that means that we need to only search the record they are from New York. Also, they have a customer number higher than 1500. Okay, so we have two conditions, right? So we're using and operators for both conditions. They have to be satisfied. Okay, included. So you can put an and, where and then we have two conditions. Okay, pretty straightforward. Then we can find all those like dev customer number. Of course, like in this one, I already saying, okay, you just need to list the customer number, name, and a headquarter. Then you don't have to give me the customer number. Okay. And another condition is or. Okay, so right here is the customer number, customer name, and headquarter. But this time it's like if they are headquartered in New York or they have a customer number higher than 1500. And this time operator means like they can be one or both or either like this. Okay, so either they are from New York, either they have customer higher than 1500 or both. So for this three condition match, they will still list. Okay, and it's saying like to be like higher in persistence or okay. So if we so we put all the ends, they consider like before any ors are considered. So be careful right here. So if you're putting like if we need to list the customer numbers, name, okay, headquarter. So they are like headquartered in New York or they're satisfied the two conditions of having a customer number higher than 1500. So being headquartered in Atlanta. Okay, so why here if you see this question, most important is say n is more like high. So when you putting the question, based on this question, when we write your like query right here, so of course we were doing the same list, like number, name, and headquarters city from the customer table. So right here, if we put the headquarters city is New York, and then another and headquarters is like Atlanta, and we in the middle you will see we have a or customer number greater than 1500. So we try to match this one is the condition. Okay, so number have like higher than 1500, also being headquartered in Atlanta. So we have a high right here. So be careful of the condition, especially when we are mixing or and. Of course, in practical, if I give you more questions, then you will see the differences between them. Okay, so if you're putting and or together, or if you want to make it easier to read, sometimes I would recommend you can put in a bracket between them. Okay, so this one and then or condition. So you're not like high, but just you need to remember and have higher procedures, precedence like that or. And also, if you really want to let the or to be considered first, you need to force it to waiting period like this. So we, as what I say, you can add in the bracket. Okay, as what I say, so you can add it here. So then SQL will consider either New York or the customer number greater than 1500, and matching is the headquarter Atlanta. But you were saying one, there's some reason if you're matching this condition. Okay, because like if you have the New York and we have another city is Atlanta, then you need to think about this one. Okay, so that's why here we only have like or damage customer number greater than 1500 and the headquarters Atlanta. So you see the result they are different if we putting them with the bracket right here. And then we have between, if you remember, you say about that. So either you can use like one way. So if we're asking the record, they are like between 1,000 and 700, okay, inclusive, okay. But if you remember in the class, when we talk about between and, okay, in there, so it should be inclusive, okay. And right here, you can either using the this first one. Okay, so you can use an and condition. Customer number is greater than or equal to 1,000, and customer number is less than or equal to 1,700, like this. Or you can directly using between and. Okay, because if you look at the document, between and also is inclusive. So we can do it in this way. So if you have some other condition, if you want to use between and, then you can change the number. Okay. And then the second one, E. Okay, this one you didn't see in a previous exercise. Okay, but this one is telling if we need to find the record there, like in Atlanta, Chicago, and then Washington. Okay, so we can put in either or condition 3 times, two. Okay, headquarter Atlanta or Chicago, and then Washington. Or you can use another SQL format is like where and then using it, this keyword. Okay, so in then you can put a bracket and then you can put 3 cities right here. That's why in the beginning when I say SQL, sometimes you have multiple way to present exactly same data. Okay, that means the result should be the same, but you have different way to write your SQL. Okay, I'm not saying that it's wrong or correct or which one is better, but we can choose a better one. Okay, but I will not saying okay if you do it this way is wrong. Okay, of course not. But if you can retrieve both result, then it would be okay. And then the next one when we handling like, okay, this one for this one, if we want to find a record like those like name begins with the letter A, I think some of you also try using A, so you can A percentage. So it's a character using for the wildcard, so to represent any string of the character. So I don't care what's the following characters, but I only care the first one, A. So we're using like. If you want to find something, right here's a new operator, like have a underscore. Okay, in here put it like. So it's like we're using only one character followed by A. Okay, so if we want to find the records for those customers whose name have a letter A as a second letter of their name, then we can put the underscore right here, like, and then underscore. So I was showing, okay, there's a one character before it. Okay, so A and then percentage. I don't care what's that following. So you can do it in this one. So specific one character followed by. If you, then maybe you ask a question like, how about 2 characters? 2? Right, so straightforward. And then if we have another question, let's say we're asking which cities serve as headquarter cities for the general hardware customers like this. Maybe when we try to select the city from customer, and you will see the duplicated records, right? So if I want to getting a unique record without a duplicate row, so we can use a distinct. Okay, so we can using distinct and the headquarter city. then we can eliminate those duplicate record. Okay, so check the question. Sometimes I didn't say, okay, don't put any, show any duplicate record, but when you see a question asking what the cities serve as a headquarter, then are you going to like showing, let's say, New York for right here 4 times, Los Angeles for 2 times? No way. So we just want to have the non-duplicate unit list. It's okay. And then another one is called order by. I think you already tried to use it, so we can order by. So if we're using order by, the result will be like you can specify like maybe one or more attributes. So if asking, here's the same question right here, listing the customer number quicker than 1,000, just need to list it in a alphabetic order by the headquarters city, then you can use the order by default. If you remember, we are doing ascending. If we need to do descending, you can put DS, okay? And next one, we will talk about more example, like if we need to like doing the before order by, we say ascending, right? So all these like the cost can be included term like ASC, okay, to representing. If you need to like really force to tell it's ascending and the end, and if you want to like say it's a descending, DSC, so right here would be descending order. And next, we'll move on the aggregation. So if you remember the aggregation we cover in this week. So this week, the first one is the FH. So you say what's the FH number. So when we select it and pass which column, so which column we're going to calculate the FH value, okay? And this one only like giving the sales number, which one, and it was that. So this one is the building function. So it will auto like adding all the value and divided by how many row. Okay, so it's the FH. And we have the sum total number. If your question, I say total number of products of the salesperson. Okay, so we can add the sum. Okay, and then next one max. So we try to search for the maximum value. Okay, among our criteria. So what's the largest number of unit or product number? 21765. That like any individual salesperson has sold. So we can like find the maximum quantities right here. Of course, we have maximum, then we have the minimum, what's the smallest number. So it's also a built-in function. So all this aggregation. And next we have the count. So count is counting the numbers of rows. Okay, that means how many rows that are satisfied of this criteria. So we can, if you remember extra or the star right here, so we can count that means like all the columns. So we can count once, or you can put in any column. Okay, sometimes I will prefer putting the primary key, let's say the sales number, product number, all this, then we can count it. So right here, we can also, it will counting as the same result. Okay, so this one, I just like using the extra is okay. When we're putting together, then we need to have like using group by. So if I ask a question, what's the total number of units of all products sold by each salesperson? So I need to group by the salesperson because I know maybe the salesperson have multiple sales. Okay, so I try to group all of them together. And then when we try to sum, we sum it by the group. So when we use it for the calculation, so we make on the several different groups of rows. So each time when we sum by the group, so each group we will add them together. Okay. It will become like subtotal, the idea of subtotal like this. Okay. Just be careful if we are using group and sum. So when they working together. And then the next one, if you remember, we also like talk about halving. So this halving is like limit the result of the group by. So based on the value calculate for each group. And when we say if we have some aggregation right here, we must to use halving. You cannot put some quantity with and condition with where. So you won't be able to get the result. So just remember, if we're using halving, remember put it with the aggregation. So we need to do it. So because right here, we need to taking 2 steps. Once like you will see at least the salesperson at least like 150, and also those total number is at least like 5,000. So if I want to know those salespersons like have like total quantity is more than 5,000, at least 5,000, that means that I need to check the sum of quantity again. So you're showing the sales number and then sum of the quantity. then I need to use halving because I need to calculate what's the total quantity. Okay. And also we try with the basic joining tables because when we using Slack, we starting from the one table. But if we want to present more information, we need to join two or more tables. Then also there's a tool specification must be made in the select statement. Once the table to be joined must list in the from. Okay. Also the join attribute in the table must be declared and matched to each other in the where clause. Okay. Also, we did this practice. So when the table names qualify, so it's required when different tables, they have an attribute with same name. So here's address, if you remember in the exercise, if we have like same, let's say we have same product ID, salesperson number, or somehow if they have same, we need to clarify which table from, okay? Otherwise, you will have error. So right here, say find the name of salesperson responsible for customer number 1525. Okay. So when we need to get the name, because we need to get the from the sales table and then customer. So we are trying to do that where. Okay. So because the salesperson number are duplicate, they are same in two tables. We need to specific the address like which tables. Okay. And then because the customer number only exists in customer tables, so we can put it like this way. So put the customer number. But if they can I also put customer number, yes, it's okay. So you can still get the correct result. And we can have more example right here. List the name of products which salesperson Adam has sold more than 2,000 units. So first thing we need to get the name of the products, right? Product name. Okay, we need to search two tables. One is the salesperson, and another one is the products, also like the sales, because we need to get it. When we joining three tables, right here you will see first condition, salesperson with sales. So we match with the sales number, and then sales product number match with the products like product number. Because salesperson and sales products, they have no direct connection. So all the information we call a transaction is included in the sales table. That's why we need to include three tables together. And this time we try to match with the sales name, items, and we need to find the quantity. So quantity supposedly is from the sales. So it's more than 2,000 units. So it's more than 2,000. Then you can get the products. So that's why we need to join three tables together. In exercise, we join two, and here we joining three tables. Even if you need to join four tables, we're doing the same, just adding the condition, okay? And we do have subqueries. It's a select, okay? It's the nested within another. So nesting can go through like several levels of select statement, and with like each success, with the select statement contain a pair of parentheses. Okay, so the innermost select statement is execute first, and then the result then I provide as an input for another select statement in the next level. So right here, you can see the example right here. If we have the subqueries, so if we need to find the name of salesperson responsible for the customer number 1525. First, we look at here. I want to get the salesperson number from the customer. Okay, which like the customer number 1525. Then I will get the sales number. Then I will try to match with the salesperson. So I put a where condition, I will match it with it. Of course, if your the question is not asking the salesperson number, but there's a list, then you can change equal sign to E. Okay. So kind of like you can thinking subquery is also alternative to join to the join function, like joining two tables together. You see there's no differences between joining together or using the subquery. But for certain questions or certain situation, we do need to using the subquery. So that's why you need to learn the syntax. So we will come in saying select from where, okay, semicolon close it. And this time, what's the condition? We need to match criteria, and we put in the bracket right here, and we can select. So this select output column, we're going to like match like with the where condition right here. So just be careful of the subquery. And for this situation, let's say we are asking like which salesperson with the salesperson number greater than 200. have the lowest commission percentage of any such salesperson. So why here is it? Oh, the question looks like so complicated. So why here first? In this situation, then we really need to use the subquery. First one, we need to looking for the salesperson greater than 200 from the salesperson and looking for what's the minimum commission percentage. Okay, here's the first one. Because when we look at this, I need to know what's the minimum commission. Okay, so next we need to select showing what's the salesperson number, right? And then from the salesperson, which condition? First one is that their sales number is greater than 200. Also, their percentage, commission percentage, is like equals to the minimum. Okay. Sometimes if you see the question like here, like minimum, then we need to select it. Then we will using the subquery. First, I need to get the minimum one and then match it so we can get it. If you really work on it, then you'll realize the problem. If you don't doing using the subquery, you cannot get that. Like who is the getting the minimum? You're thinking this question looks like pretty easy, but if you want to select exactly in this way, you need to use the subquery. Okay. So say just like repeating this one, who has the lowest? If the lowest, then you need to using or like who have the highest. So you need to using max. Okay. And you can try if you doubt about it, saying why couldn't do that. So you can try without using the query. And let's see if you can get who has the highest commission percentage. You realize that you have no, so that's why you need to use the query, get what's the lowest commission percentage, and then we match it. Okay. And kind of here what is the strategy, like telling how to writing the SQL select command. So first let's determine like what's the result of query to be and write the needed attribute and function in the select code. So here's important. So first look at the question and think what's the result you need to presenting, okay? And then determine which table and look at which table of the database will be needed. Okay, so you can check and then we can put it like in the form. Okay, if you just need one table, just put one. If you realize that the data that you need to select from the query including two tables, then you can put two tables, and later you need to find in what's the foreign key, or then later we'll talk about this, and then you need to join them together. If they're involved like join, then begin with construct the where cost. Okay, so equating the join attributes from the table. So they are from the course, and then later we need to fill in the details, right? Where course also, are we using some group by or subquery, say order by, all this, okay? And just like give you some example right here more. So here's the table. Sometimes we're representing, okay, the table is here, attributes, and then what's the publisher tables, which table was the columns, and then we do have like the underline is the primary key, okay, and then dash is the foreign key, and then we have the some transaction tables, okay. So if to underscore, that means the combination key like here, and you will see more example. Then we can try to select it using where. Okay, if for the string we need to using the quotation, double quote or single will be fine, but just be consistent. Okay, and then order by. So we try to like list it, and there are some more like we can put in like in condition. Okay, and then greater than equal to condition, and then we say how many books, at least 400 pages. Then we can using can. And if we need to match more, like we learn what's in, so we say what's the publisher in Belgium, Brazil, Singapore. Okay, so we can using in, and then they were born before 1920, born before, right? Before should be like less than. To be careful of the year, okay. And if we need to getting the data or the publisher name, maybe it's going to be it's going to be duplicate. Then you need to add this thing. And right here, you will see maybe the end condition, and we will see publisher, how many books did each publisher in different country, and if they are right here, if you see they have different condition like two, because you see the separation, okay, from the semicolon, that means that okay, maybe and then putting or. So right here we're using the bracket, okay, to put them together, and even though we say N have a higher um precedence than O, but we also like try to showing they are in right here. So you see the first bracket right here, and then just putting N, publisher and goodbye. And next will be showing if who has the, if you look at question, so which one has the earliest publication years, then we need to use the subsequent, right? And another one is the World Music Association. You can see all the tables. If you later you see the exercise, if giving you, and then I give a question. So what's the total annual sales, of course? Then you need to select it. Okay, so you can put in some, where, condition, and end. Okay, so this one is about the violin. One is of the Berlin. Okay, so then you can put it. So what's the total? Then we using some. I also make a list. Okay, so in alphabetic orders. Okay, so right here I didn't mention about ascending descending, so we can assume it's the ascending. So by default, okay. So we just go through like what's the order by and all the condition and joining tables. Because when you see we cover 3 tables. More right here, so maybe you can like adding the sum, and we do have a goodbye and condition, and using having, because we want to check like for the annual salary, okay, exceeds, okay, that means more than 1,500 thousand right here. And more, maybe we're using a Sakura was the most highly paid, okay, pianist, okay, so right here. And also we have multiple, you can see the subsequence as left from, where, condition, and then this also need to joining table. So you will see the structure getting more complicated. So when we're setting the max salary, but also we need to joining 2 tables, then we can get the maximum salary, because it asking what's in name of the most highly paid pianist in any orchestra in the Australia. Okay, so right here, so we need to get the name and then move and then what's the instruments, country. Okay, so we need to get the salary, because we also, if you remember, we need to get the highly paid, right? So maximum. But for this one, if we need to get the high is pay based on the location. Because if you don't put in the instrument and country, then you will get the highest, but they may be not belongs to the instrument or the country of Australia. So you need to be careful and just keep going more. And right here, just repeating. So we are like using like to handle with the string, like begins C or the letter D. Okay, so we just like beginning with D, and I don't care what's the remaining character. Okay, and then the country is in Japan. And also what's the average mileage of the car. So that if I tune up in August, then you can check like the date. So also we can put the date. Just reminding for the date, we can follow the format. Okay, August like this, or for this one, we need to check the format of the date. Sometimes I will get you like for the question, so you won't like confused. And also we have another data type later when we cover about the metadata. So it's like describing the attributes or columns. And we have different telling times and then timestamp, okay, all this. But this one just the date. So we can use in between and also another question, this one is pretty straightforward joining and then using count. And when we count, also we can adding the distinct model. So we have like how many differences car models do manufacturer in Italy make. So we're from Italy. So we try to match it with the 2 tables car manufacturer numbers. So right here we try to get the what's their distinct model, then we can count it. Because we don't want to getting duplicate models, right? So be careful. Also, we can using this thing with the count function. And then we keep going. We're using like having count. So I don't care, just counting the row, and then more than 3, more than equals to at least like the result there, at least like 3 repairs. So we're checking like within the time. Okay, so the date between and goodbye their car number. Okay, and then we try to count the how many times they show on the record. So we're showing the car number with the count, then which manufacturers be like Super Motors. Okay, right here. The next one, which are list the cars of manufacturer they have an oil change. So we want to get and at least as a many miles, okay, as a high mileage manufacturer right here, and then maybe like change at the same month. So we're going to, you see, we have the subquery. So subquery manufacturer time, procedure, oil change. Okay, because we need to join in two tables and we try to get the maximum mileage. Okay, so finally the subsequence we get the mileage match the condition we mentioned right here. Then we need to show the car number from which a maintenance, okay, oil change between that time. If they're more than the maximum mileage, so then we can get what's the at least many mileage. So you see when you see the question, say at least, highest, okay, then we need to use the subquery and then using max or minimum to get it. And last, reminding you just like for relational query optimizer. So we need to know two things, like relational DMS performance. One is the query optimizer concept. So the speed like with which the query data can be retrieved, the performance regarding John like is a particular problem. So we try to like turning of the database structure, physical database design. So it's one way. And also the relational query optimizer software, they will evaluate each like SQL statement to determine an efficient way to satisfy. So here's the one for optimize it. And then all the major SQL processors include query optimizer. So all these. So when we use the query optimizer, the SQL attempts to figure out the most efficient way of answering a query. So prior to actual responding it. So this optimizer, so using the relational catalog as an internal database. So right here, maybe like we have certain consideration can ask for the optimizer. So which attribute have index? So later we'll talk about indexing. For when we also when we design a database, we need to think about how can we build the index over them, or how many rows does each table have, and which attribute they are unique. Okay, and how many records of tables are really need for a particular job. So you need to search for it, and which job algorithm is the best like for this query, so they can consider all this like for the query optimizer. For the job algorithm, we think about the nested loop job, so that's has been imported. So one of the two tables select for the outer loop and the outer for the inner loop. Okay, and then the each of a record of the outer loop is chosen in succession, and then for each like inner loop table, so they are scanned for the match of the joining attribute. So this I talk about was the joining algorithm. So which table come first and then the second. So later when we have more example, when we talk about joining tables, then you will have a better idea about the joining algorithm. And then one is they call the merging scan. So it's more like efficient than the next loop joining. So only be used if the certain conditions are met. So you will see that faster if they are meeting two of them, they are joining attributes that have to be like short order, or two attributes that an index built on it. If though both of them they already have an index and or shorter order, then we can use the merge scan join right here. So when we quickly go through all the database, thank you so much.